All right. Hello, everyone. I think we are live. And yeah, welcome to a new session here on the OllyGarden YouTube and LinkedIn channel about a new topic. Today, we are starting a kind of a new series, AI meets OpenTelemetry. And the first part of the series will be how and why to instrument your OpenTelemetry or your AI agents with OpenTelemetry. Which is, I think, a super interesting topic. I'm primarily working on our Rose project, which is an AI agent, and there we've been using internally OpenTelemetry to instrument and observe our agent. So yeah, that's pretty cool. And therefore, I want to share some insights, what we learned along the way, but also some basics about what an AI agent is at all. So without further ado, I would jump right into it. And folks, whenever you have a question or whenever something comes up, just drop a message in the chat or reach out after the live stream. We're happy to talk about your questions. All right, I'm gonna share my screen and start. All right, perfect. Like we talked about how and why to instrument agents. Now, let's first of all have a look about what we're gonna talk about today. I want to start with talking a little bit about what an AI agent is at all. I mean, there are a lot of buzzwords out there these days with AI and what you can do with that and MCP and agents. So just to get everybody on the same page, what an agent at the end of the day is, and then why we should instrument it or why we care about instrumentation there. After that, I want to go a bit more into detail how we can instrument the agent. There are different approaches out there, what you can use and how you can instrument such an agent. And all of those different approaches also have their own pros and cons. So I want to talk a little bit about that. And then in the end, we come to the final part where we actually, first of all, instrument our agent live, or I prepared the instrumentation, but I'm going to show live the instrumentation of our agents. And in the end, I will want just to wrap up with some do's and don'ts, what you should watch out for when you instrument your agents. One thing I want to mention up front is we will focus on anything OpenTelemetry native. So I know there are a few frameworks out there which build on top of the OpenTelemetry SDK. So they basically reuse what's already there to make it easier for you to instrument your agents with abstracted SDKs. But for the sake of the presentation here, I really want to focus on everything which is provided directly by the OpenTelemetry project out of the box. With that being said, let's have a look at what an AI agent is. Now, essentially, when we think about an AI agent, we can think about an infinite loop, which is just running and running and running and running. And in there, we have an LLM model, which has access to tools. And then we give a certain prompt, for example, how's the weather today? Like in probably every AI agent demo or quick start you find out there, like how's the weather today? And then the AI agent is kind of working with that prompt, and either it thinks about it or it directly calls some tools or responds to you. And the reason why we have a loop is that the agent decides if it needs to think, if it needs to call a tool, or if it's finished and ready to answer to us. So that's like the idea of an agent. And yes, it's that simple. At the end of the day, it's just an infinite loop with an LLM model and access to tools. And by the way, I can highly recommend everybody either to really learn about how you can build such an agent, because it's quite easy, or if you have a few hours free time, just build it. You will learn so much about how those agents actually work behind the scenes, or what's happening when you, I don't know, use ChatGPT, what's actually happening in the background. Now, to speed things up a little bit, I prepared an agent dedicated for the session here, simply to have something we can instrument and we can have a look at. In our case, it's an OpenTelemetry semantic convention agent. It's not that powerful, so unfortunately it won't do much because it's just for the sake of the demo. I've written it in Python because there we have the option to do two different instrumentation approaches, to which I will come later on. And here we can see how such an agent might look like. So you can see it's exactly 70 lines of code. It's pretty much simple. In the top, we're defining which tools we give to the agent. So in our case, our agent has access to read files. It's like the cat command or the cut command. If you might use like your terminal, we have the grep tool where it's able to look for certain strings and files. And we have the list tool where it's able to list the directories or the contents of a directory. Then we define a system prompt over here, which is pretty basic and not really fine-tuned, but it's enough for the sake of our demo agent. And down here, we start our agent processing loop. So first of all, we are capturing the user input. And then down here, our infinite, like I mentioned, agent processing loop starts. And we will continue as long or until the agent thinks it's finished. Now, in a production-ready agent, you of course want to have certain guardrails around that. So you would likely say, okay, whenever you are in like a dead loop where you call 10 times the same tool and you always get back an error, then you likely want to exit that loop so that you don't repeat and repeat and repeat, repeatedly call the LLM. But in the end, it's just that, what you see here. So we're checking if the LLM wants to call a tool. Google is calling it function calls. So we're using the Google Gemini models here for the sake of the demo. Google is calling it function calls, but it's just tool calls. And then we will execute all of the tool calls if the model wants to do so, or if not, we will respond back to the user. One last thing, which is interesting about the agent, that innocent looking line here in line 23, I hope you're able to see it big enough. It's just an empty list at the moment when we define it in here, but that's like our conversation history. So whenever an interaction is happening, whenever we are asking, whenever we prompting the LLM something, we add that to that list here. Whenever the agent responds to us, that will be added to that list as well. Whenever the agent is doing a tool call, that will be added to that list as well. So it's really like the history of our conversation. And when you think about it, when you're going to ChatGPT or Claude, that's like our context window, which is filling up. So different models have different context windows, and everything is stored in such a conversation history. Of course, in our case, it's very simple. It's just a list in memory in our program. ChatGPT and other tools are storing it persistently somewhere, but that's the idea of that message conversation. If you're interested in having a closer look at that code or playing around with that agent, feel free to scan the QR code or just open the link here. It's available public on our OllyGarden organization in GitHub, so you can have a look there in more detail. Now, enough about the agents and what agents are. Why do we want to instrument agents at all? Well, setting up an agent is quite easy, as I just showed you on the previous slide, and I will give you a demo about the agent, no worries. We will have a look what the agent can do right now. But the point is there is much, much more than just building the agent itself. When we build the agent like I showed here, we might be able to use that on our machine for our private purposes to tinker around with that. But as soon as we start thinking about putting our agent onto production, that won't scale. We need to know how our agent is performing. And that could on one side be how I like to call it, like the operational aspect or the operational context. That means the latency of the agent. How long is our agent taking until it responds to the user? How long does the user needs to wait? How many or is the agent available at all? Maybe also which provider is used. For example, you could use the OpenAI models via Azure or via OpenAI itself. Like that might be an interesting indication what is used there. And then on the other side, what I like to think about is like the business context side of things. And there it's really about, okay, how is the agent behaving? What is the agent doing? Like, is it calling the tools which it should call? How much space is left in the context window? Are the responses from my agent complying which I allow or which I would expect should be part in there? Or maybe is somebody messing around with my agent and trying to inject some malicious prompts? Those are important things to know. And that's like a whole different set of things. So on one side, we need to know if our agent is working, how long our agent is taking to respond. And then on the other side, we want to know those agent-specific things like the context window, the tokens, and so on. We will also go into that in more detail later on. All right, enough of the theory. Let's have a look at how our small demo semantic convention agent is actually looking like and working. I'm gonna switch the windows. So it's gonna take a second. And you should be able to see my terminal. There we go. And in here, I just prepared the agent, and I've showed you the code for the agent earlier. And what I'm doing here is I'm just calling the agent. So that Python file, which I showed you, I'm just running that. I put that in a make file to make it easier for me to use it here in the demo. But at the end, it's just running the Python main.py file. I'm gonna say make plain. That means I, for now, want to run it without any instrumentation to show you how it's working right now, without any OpenTelemetry instrumentation applied at all. So I'm gonna say make plain, and then I'm gonna say that I want to use the flash modal. In that case, I'm gonna hit enter, and now you can see our agent is starting, and it's asking us for our first input prompt here. So I'm gonna say, hi, who are you? Just to see if the agent is responding to us. And yes, it's responding. I hope you're still able to see the terminal, because something seemed to have happened here. Okay, I'm not sure if it's still visible. I'm gonna switch over to cursor. Maybe that's looking better over there. Okay, now I think we're back. I don't know what happened, but now you can see here our agent response, what the agent told us, who he is. He is an OpenTelemetry semantic convention assistant with access to our file system. We gave it a few tools like I showed earlier. So that seems to work. That's cool. And now I'm going to exit here again. And before I go into more detail, I want to talk about different instrumentation approaches. So we know our agent is working, but how can we learn more about the behavior of the agent? And that's exactly where the OpenTelemetry instrumentation is getting interesting for us. So there are essentially two main approaches you can do. It's on one side, the automatic approach, where you auto-instrument your code. There you basically don't need to do any code changes, and you will receive insights about how your agent is performing. And there is an option to manually instrument your agent. I prepared a demo of both of those approaches. So I'm gonna open up another window where I quickly want to show you how you could do the first approach, which is the automatic approach. There is an OpenTelemetry Python contrib repository in the OpenTelemetry project. And in there, the project is providing certain auto-instrumentation libraries. In that example here, we are using Google. So we can make use of the Google auto-instrumentation package here. And that makes it very, very easy and quick for us to set up an initial baseline of auto-instrumentation to see what actually is going on. Because as you saw in the earlier interaction, we sent a message to the agent, but we didn't know how many tokens were used, how long it took, which model was used. So there would be no way to see what is going on. So let's switch back to our terminal and have a look at our auto-instrumentation or our auto-instrumented agent. I'm gonna run the make auto command, and again with the flash model in that case. And now it will load the code of the automatic instrument agent. And maybe one thing which I will do before I go into more detail, I just want to quickly show you how the code of the auto instrumentation is looking like. So maybe you remember the code which I showed you earlier, and even with the auto instrumentation, the code will stay and look exactly the same like before. So we didn't touch anything. We didn't change the way how we call the LLM. It's still exactly the same. The only thing which changed is that we installed a bunch of additional packages to our in our requirements txt, basically the Python packages which we need for our application to run. And then we define a couple of environment variables, for example, the service.name, like how the service should appear in our observability backend. The endpoint, in my case, I'm running Grafana locally, to which I will send our traces, which the agent will produce in a few moments. That would either be your collector or your backend, if you want to test it with your, or if you want to clone it and test it on your own. But in here, nothing changes. And we will just start the agent, or we will wrap the start of the agent with those prefix commands here. So we're going to say .env run OpenTelemetry instrument, and then we're going to run our application, and we will get out of the box telemetry with that little change. Now, as promised, I prepared that, and I'm just going to run that in the meantime in the background. So I'm gonna go over here and share my screen to the terminal again. And I'm gonna say make auto. We again will use the flash model. It should start, and now I prepared a small prompt where we can actually test if our semantic convention agent is doing something. So we are saying here, based on the semantic convention documentation, explain in concise bullet points how you should write good new semantic conventions. We triggered off the prompt, and in fact, we're getting something back. So it's telling us, okay, you should, or your conventions have certain requirements. You should use prototyping for your conventions, how you can define them, and so on and so forth. Now, the reason why I explicitly wanted to tell the agent to look at the semantic convention docs is that as part of the demo, which you can see here on the right, I added the semantic conventions repository into my local directory here. So I would expect the agent to use the tools which we defined earlier, for example, the list and the grep or the read tool, to go into the semantic conventions and find the content which is relevant in order to give an answer to the questions how you can write good new semantic conventions. And apparently it worked. It worked well. So our agent was able to tell us how to do it. So if you go to the semantic conventions docs, you will find the how to write conventions documentation, which basically mention a few of the points which you will find in here. Now that's cool that our agent worked. Now let's have a look at how the auto instrumentation is looking for that. If I switch back to Grafana, like I mentioned earlier, we can already see that quite a bunch of things are going on here. So I did a few tests before the demo, so I'm gonna change it to the last 5 minutes. And we can see, okay, we have a few new traces, what we can see here. We see our service name, what I shown you earlier, what we defined in the environment variables. And then we can open those traces and we can see, okay, we are sending a post call to a certain endpoint. In that case, it's the Google Gemini model. Now, the first thing we notice here is, or the first thing which seems a bit odd is we have 1, 2, 3, 4, 5, or we have a lot of different spans, but they actually belong to the same agent execution. So the problem was that our context or our agent context was not really grouped together here, because the auto-instrumentation is just saying, okay, we're calling the Google Gemini model, let's create a trace for that. But it's not understanding that we want to see what the agent is actually doing. So we didn't see when the agent decided to call the read tool to understand what's happening in that file. And that, of course, is not ideal for our production agent. If we think about like to trace down how our users are experiencing our agent, that won't be sufficient to see what is going on with the agent. Now, the good news is we can do something about that. Bad news is we need to change our code for that. But I will promise you with the few code snippets I'm going to show you in the next slides, you will see it's actually not that hard. So I'm going to switch the tab and go back to our slides. And one thing which I like to do is, and which I also recommend to do, whenever I instrument an agent, I recommend you to kind of build your mental model. Like, what operations or what tasks is your agent performing you're interested in? And oftentimes you could probably categorize that in those three categories, which I have written down here, like the agent invocation itself, when you start or when you launch the agent, the inference process when you call the model, and then you might be interested in which tools are called when. But in some cases, you're maybe only interested in a certain tool code. For example, if you, I don't know, if you're building a web search agent, which is doing some kind of web search, you likely are only focused on the web search tool calls. If you're building an agent which is a coding assistant, you might be interested in all the read and write tool calls. If you, again, have a completely different agent, you might not be interested in tool calls at all. So I would really try to, first of all, think, okay, what am I interested in when I build my agent? And then what I recommend is create reusable helper functions. So those are basically three very small functions which I prepared. They are also in the repository, which I linked in the beginning of the presentation, and they aim to facilitate the starting process of different operations. For example, like I said here, to start the agent, the inference, or the tool calls. And it will create a span with semantic convention attributes here, what you can see, which already give us a very, very good baseline out of the box. Of course, there are more semantic conventions you could and you should set depending on your use case, but I wanted to keep it as simple as possible. And for Rose, for example, for our OllyGarden AI instrumentation agent, we are doing the same. So we are not using Python there, or not exclusively Python, but we also have similar helper functions which help us to set those attributes and which help us to create the spans in that way. The same we will need for like capturing the tokens. So whenever the response from the LLM is coming back, we need to track, okay, how many tokens were part of that response or of that inference process. And we would be interested in capturing the error or the response. And one thing which I want to point out here is the capturing the input, the output, and the chain of thought of models. So what I recommend you to do is, and also I think what the semantic conventions are recommending, you should add a condition you should have an option where you can toggle if you want to capture input and output of your agent, because there might be sensitive data or sensitive values in there, or your users might not want that you can see all of their queries in your observability backend. So what I recommend you to do is to maybe control that via an environment variable. And then on dev, you can enable everything, because there you're interested in seeing what is actually going on behind the scenes. And then on production, you likely want to limit what you're capturing to protect your users' data. Now, when we translate the automatic instrumented agent or our agent without any instrumentation to the manual instrumentation, it now gets very easy. Now that we have those reusable helper functions, we just add 1 or 2 lines of code and we have the process where we create the span for the agent invocation. In that case here, you can see when we start the agent itself, we start the agent invocation span, which will capture the whole runtime of our agent, or the whole duration of the runtime of our agent. The same goes for the LLM inference. So here you can see we are wrapping the LLM call again into a span, which will have the agent invocation as parent span. It's again just one line of code. And what we are doing here in addition, we are recording the response, including the token usage, what we are getting back from the LLM. So because of the helper functions, it's quite easy for us to simply pass in the tokens and without much effort in order to capture those details. And surprise, surprise, we're doing the same for the tool execution. So for the tool calls, we again simply wrap it in our helper functions, which I shown you earlier. Now, that's the theory about that. So as you can see, it's not that hard once you have your mental model in place and once you have those helper functions in place. But now to the interesting part, how is that now looking like in our observability backend? So first of all, I'm gonna trigger the manually instrumented agent. I'm not gonna reshare my screen because it will look almost the same like it looked before, just with the manual agent. Or you know what, I will quickly share it just to get everybody on the same page. All right. In that case, we use the manual instrumented agent, and we again want to use the flash model. We put in our prompt again, that we want to learn about how we can write good semantic conventions. It's gonna do some work now, which is good. So our agent is probably using a few tools behind the scenes. And there we go. We got our response back. It's looking quite similar to what we saw before. And I would have been surprised if it's looking different because it's still the same agent at the end. But now the interesting part will be, how is that now looking after we instrumented it manually? And therefore, I'm again gonna switch back to Grafana to explore if there are any new traces. I'm gonna run the query again, and there we go. We can see now we have a new service agent with manual instrumentation, and the first thing we can already point out is there is only one trace, which is a good indication that everything was captured as part of one operation. And also, if we open the trace, that's looking much, much better now. So we can see what happened when we initially provided our execution or the invocation of the agent. We can see the first prompt. So I enabled that I want to capture the input and the output for the sake of the demo. We can see which tokens were used according, based on the semantic conventions which we set. Like I said, the input messages, and we can also see like which tools were called when. So what I find in particular interesting here is we can now exactly trace down what our agent was doing. So after we told it that we want to learn more about how we can write good new semantic conventions, it first of all used the grep tool to see, okay, is there anything related to semantic convention docs? It didn't find anything, so then it was again thinking in our infinite loop, if you remember, okay, what can I do next? And then it thought, okay, let's have a look at our directory or at our available contents. And then it found the semantic conventions directory or the repository. And in there, it again used the list tool to see what's in that repository. And then it eventually found, okay, we have the file path contributing MD in that example here. It read it, and based on that, it responded to us. And without manual instrumentation, we wouldn't have that information. We would see, okay, we did a few calls to the LLM, but we wouldn't see what actually is going on behind the scenes. And yeah, so that's really the cool thing. With just a few lines of code, we can actually see what is happening there. And therefore, I'm highly recommending you, when you want to instrument your agents with poor OpenTelemetry native SDKs, try to use manual instrumentation because it will get a lot better, or you will get a lot more insights. Now, let's go back to our slides because I have two more. And I know we're running out of time, so I'm trying to hurry up. I just want to recap what we just had a look at. Um, First of all, again, you likely don't want to capture LLM input and output or the thoughts of the LLM model on production. You should make it in some way configurable that you avoid capturing sensitive details. What's highly recommended, or what I recommend you to do, is before you instrument your agent, think about what do you care about? What are you interested in? Which tool calls, which LLM calls, and so on. Then you build your reusable helper functions, and then you have quite easy option to wire that into your agent logic. One more thing, which I think is important to mention, is span attributes with a focus on usage tracking and billing. So in the beginning, we talked about, okay, we might want to use our OpenTelemetry instrumentation to track the tokens or the context window. And that's right, it will be helpful to do that. But what I would recommend is don't poorly rely on that if you need accurate cost tracking for billing purpose. The reason why you might easily miss things with that is sometimes some traces might be sampled out depending on your sampling strategy. On production, when you have 1 million agent invocations a day or a month or whatever, you maybe don't want to capture every single trace, but only when something goes wrong. In that case, you miss those captured tokens. So either you're really conscious about what you're doing, and you need to be aware that sometimes you might also lose a trace because of some network issues or other problems, or that you might sample some things out. So if you want to use OpenTelemetry or instrumentation to bill your customers or your users with those tokens, just keep that in mind. And like the final point which I have is it might seem a bit tedious to do what we just did with the manual instrumentation, to think about that mental model, to create those helper functions, but I think it brings a big benefit. So in times of AI, where like every month or every 2 weeks almost, there a new framework or a new model appears, you want to have full flexibility. You want to be able to move fast. And I wouldn't limit myself or my agent to be forced to use a certain framework or a certain instrumentation approach, which doesn't give me flexibility. I don't want to limit myself. So I want to be able to move fast. And the great thing about OpenTelemetry is that usually most of the frameworks out there, they build on top of OpenTelemetry. That means if you set your base instrumentation in your agent with OpenTelemetry as foundation, you will likely be able to switch easily to a different provider, to a different framework, to a different agent orchestration platform, whatever, because usually OTel is accepted there, and if not, you can maybe ask if they can support it, and then you really keep that flexibility, which at least for my case, but when I build agents, let me sleep with more peace at the end of the day. And that's what I'm mentioning here is, so I pulled out 2 screenshots from actual traces, what we have for Rose. Those are from local development, but still, these are actual traces. And like I mentioned, we are fully instrumenting Rose with OpenTelemetry, so we are not using any third-party SDKs or something else. And on the right, you can see Langfuse. It's an open source agent or AI observability. No, it's not an observability platform, but like an AI agent management platform. So you can have observability there, you can manage your prompts and so on. But the point is, we're using OpenTelemetry behind the scenes, but still we are seeing exactly what is going on here. And in that case, we are using Langfuse to learn more about the business context, what I mentioned earlier, like how is the agent performing? How are the answers from the agent? How many tokens am I using? How much space is left in my context window? So there, Langfuse will provide us those answers, but all the data is coming from our OpenTelemetry instrumentation. If we decide tomorrow to switch to a new platform, no problem. They just need to support OpenTelemetry, and we still will be able to see the data like before. So that's really the beauty of that. And at the same time, we can use our instrumentation to not only capture those business relevant details, like I mentioned earlier, but also to capture the operational context of the operational aspects of our agent. So we can see, was our agent available? How long did our agent to finish the execution? In that case, here on the left, we can see how Rose performed a code review for a Go code base. And here on the right, so both of those information you can see here belong to the same operation and to the same instrumentation. And on the right, we can see what actually the agent was performing and doing. And that I really think is the beauty of it, and also why you might be interested in using OpenTelemetry to instrument your agents. So yeah, that's about the presentation about AI agents and how to instrument them and why you should instrument them. I hope I didn't miss a question or something. I'm not seeing anything right now, but in case I have missed something, feel free to reach out to me on LinkedIn or just send us a message. We're happy to answer those questions. And if you're interested in more topics in that regard, like agent instrumentation or other approaches about AI and OpenTelemetry, or if you want to learn more about Rose, how Rose can help you as our agent with your instrumentation, also feel free to reach out to us, and then we can set up more sessions in that direction in the future. All right, with that being said, thank you very much, everybody, for joining. I hope you liked the session, and yeah, see you the next time. Bye-bye.